We have a MacBook Pro, and it's a 13 inches, and it says no power. The model number is A2338, and that's the MacBook Pro M1. Okay, so as you guys know, it's a no power. We are not going to plug power to it until we are sure what is happening inside the device before we plug power to it. So we basically plug power to the device when it is time to do so. So right now it's not time to plug power to the device. And then also you may say, okay, but then how do you know that the device is not just requiring a charger? So 9 out of 10 devices that we get are coming in as advanced repairs. So they go through an assessment process already. The technicians do the assessment, and only when they find that it's an advanced repair will the device come down to the lab. So when the device comes here, it's 9 out of 10 devices that we get. They are going to come from pre-assessed desk. So we basically take it up from where they stopped, and especially and then even though this is coming from a client, the right thing to do is for you to get a look inside of the device before you connect chargers to it, even though it's not been pre-assessed. But back to this particular device, it's already been pre-assessed, and then it's been determined that it's a low power. So what you are going to do first is to take the board out, and then also you guys see the other thing that I do. So I do not take my screws out with the screen closed like this, because I don't want to run the chances of obviously applying pressure on the device and thereby cracking the screen. So what I do instead, I make sure the screen is open, and then it comes like this. So that way my keyboard trackpad is the only thing that sustains the pressure. So, okay, let's begin. Actually, okay. Um, okay, so this has been definitely this has been hands in here, as rightly so, because the device has been assessed. So first thing we will do visual inspection. Um, okay, so we don't see any sign of liquid ingress. So the next thing we are going to do is to disconnect the battery, which is this guy here, the battery data cable, and that is the main battery power line. And we are going to use our multimeter to see if we have a short on some of the common power rails on the machine. The board number for this is going to be 820-0202, 820-02020. So let's open that up. 820-02020. Where are you? There you go. Okay, this is our board view. So we are going to check to see what we have on our PP bus at F5200. This guy here. This guy here. We our multimeter is in continuity mode. we'll place this on ground and then the red probe. Let's see what we have. We don't have a short. Now let's see if we have a short on our 5-volt line, because that's one of the, sometimes it's a common issue that I pick up. So at UC300, sometimes I pick up an issue by UC300, and then it creates, it results in a short that you can pick up an LC3220, which is an inductor. So let us see if we have a short on the 5-volt line. And we don't. Okay, so the next thing we're going to do now, so it's now it is clear that we don't have a short on our PP bus line, so we can now connect power to it and see what we get. Let's just confirm that our charger is working. Okay, yes, our charger is working. Now let's see what we have on PP bus. If we get 12.0, it means our device, it means we're getting 20 volt on our PPDC in. If we get 12.32, it means we're getting 5 volt. So let's see what we have on our PP bus. So we can measure for PP bus on fuse here. Okay, 12.27. Yeah, so that's, we are getting 5 volt on our PPDC in. So now we want to take the board out and get to know why we are getting 5 volt instead of 20 volt. Okay, now the screws are out. The next thing is to disconnect all the cables. We are not going to worry about this section of the board because we have no business here. So, and also we have the rubber that goes over the heatsink that is missing.
Just a quick one.
Go ahead.
You said when sometimes the machine is a bit TFU,
Yeah.
we get 5 volts.
Yes. Yeah. And not just DFA, also when it's stuck in recovery sometimes. And but in terms of when it is stuck on recovery, oftentimes when it's stuck on recovery, you will get a haptic feedback. which in that case is going to be the device is partially in SO state, and also because it's partially in SO state, it means you'll be getting 20 volt and 12.0 volt on your PP bus as well. Okay, board is out. Let's now see what is it that we have on the other side of the board. In our visual inspection, we'll be starting from right to left just to see if anything stands out. Oh, by the way, just so that we said initially that if you get the voltage is how you can easily work your way around what is it that you have on your PPDC in. So let's go over that again. So we said that when you get 12.30 or 12.20 something, that means that you are getting 5 volt on the PPDC in. That's on PP bus. So let's see. So 12.26. So that 27. So that means that we're getting 5 volt on our PPDC in. So if we flip to the other side, PPDC in, we can measure at this fuses here. So let's see what we have here. And you see that is 5 volt. Now if that was higher than 5, if that was 20 volt, then we'll be expecting to see 12.0 on our PPDC on our PP bus. Okay, so that's just what we needed to confirm. So having confirmed, so the next thing we're going to do, the next thing ideally we would do in case of troubleshoot, because right now what we are going to do is to troubleshoot while we have 5 volt instead of 20 volt. So we're supposed to get 20 volt and not 5 volts. So let's open up the schematic real quick. 820.0.2020, 820.0.02020. Where are you? 020. Okay, let's search that.
02.
0200 02020. What? Oh yeah. Okay. Okay, here we go. So let's go to our PPDC in circuitry, which is going to be, let's say UF400 and UF500. Okay, UF400, yeah? Yeah. UF400. Okay, so here it says HV power aliases, and then here it says PPDC in USB-C underscore, so PPDC underscore USB-C underscore AON, which means it's what? It's always present. And then here we see what it says. It says here, what does it say there? 20 volts. So that's what we're expecting. And these are the two fuses. FF200 and FF201. Let's just quickly go back there. So FF201 and FF200. Yeah. Okay. So we have checked, and so here you can see because they are linked. Where were you? Because they are linked, it means that if you're having 5 volt on one, definitely you're having 5 volt on the other. Which would also mean the ideal situation would be if when you're getting 20 volt on one, you should be able to get 20 volt on the other. So that is an ideal situation. So let's check the second port and see if we have. So now we measured one port and then we're getting 5 volt. Let's check the second port. So say for example, if we measure one port and we get 5 volt, and then we measure the other port, we get 0. Then we get 0 volt. That is a giveaway to tell you that that particular port is the reason why the other port is stuck on 5 volt, because the two CD3217 are going to work in unison. So what that means is the working condition of one is dependent on the working condition of the other. So if one fails, depending on what region of the chip that fails, if it's alongside the communication line or alongside the communication line between um, the A and the B, then the B will not work. But if it's outside the communication line of the A and the B, then you will have one port not working, but it will not prevent the other port from working. So, Osman, you follow? Okay, so we have 5 volt. Okay, that's fine. So the next thing we're supposed to do now is basically check out to see. Let's see what we measure around the CD3217. But before we do that, let's check to see if I have a short here. This is our multimeter. We're going to come back to that. So first of all, we check to see if we have a short. If we don't have a short, then we can now come back to our CD3217. Let's see, because especially on the M1s, the pros, it's a common failure here to find the short. So that's why I want to quickly check that out first. That's fine. Okay, so you see that? That's a short.
Which line is this one?
Yeah, remember that. Remember the line that goes. So I'm just gonna show you. So you see that guy here. You see that, and then we go to the other side. P7700. So let's open that up and see what is going on. Hmm. So let's see. Uh, it's not so we don't see any sign that this has been affected. Okay, so which means our problem will most likely be in one of the caps here. So the easy thing we're going to do, so let's see, let's go to the other side. We are, let's see, okay, so that is sitting on pp3v3 underscore aon. So that is like the 3.4 volt on previous designs, 3.8 volt. So now what we want to do is we are getting a short here, but that short may either be on the line of may either be on this line or the line of 3.3 volt, 3.8 volt. So what you're going to do is remove the current sense resistor to see where the short is, if it's on this side or on this side.
Okay.
You understand? So let's remove that. Osman, do you understand what we're doing? Yeah, but even if you don't understand, over time you will pick it up. Sometimes it may just look like a movie, especially in the very beginning. But as you move on, you will get to understand what you're doing. Okay, that is out. And by the way, the 3.8 volt line, it's critical for the creation of your 20 volt. So if you don't have that, you're not going to get 20 volt, which explains why we do not have 20 volt on our PPDC in. But then there's also another troubleshooting concept to understand here. So experience also plays a huge part. Primarily, if you don't have PPDC in voltage, you want to go straight to the controller, which are these two guys here. Yes. Yeah. But in this case, because of experience, yes, we are going to go back there if the others check out. You see? So also part of that line is also going to be part of what we will find here, which is the 3 point. If you check here, the 3.3 volt line, uh, Let's see. So you will realize that this line here will play a major role in the creation of your 20 volt. So because that is not present, that's one of the reasons why you do not have the 20 volt. So the next thing we want to do is we now want to see where the short is, if it's on the side of 3.3 volt or on the other side. So with that resistor out of the place, and this is fine, we don't have a short there, so our short is on the side, which gives us a narrow down. To now let's again look to see what is it that could stand out. So our problem is not on the side. So let's see on that line, and then let's see. Let's see what we get on a Wi-Fi module. Okay, my Wi-Fi module is not shorted. That's good. We don't have a short on that side. So here, let's see, any type of isolation to do again.
Or you can even find two isolations in one line.
See, for example, say that 1.8 volt.
Oh yeah.
See here also, and then it goes. I don't even think that's present on the board. That should be no stuff. Yeah, it's a no stuff. Okay, and then this one here, is that present on the board? No stuff. Okay, let's go to, and then this side, let's see what does it look like. U5000. This is going to be U5000. What does it look like? It doesn't look bad. That doesn't look bad. Okay, let's see what else. And then on this side, then you also have that, which will go to your power button. Let's see what does that look like. So that's this guy here, and then the other side, let's flip it to the other side. So let's flip the board to the other side. Does anything stand out here? Okay, nothing stands out there. Okay, which means we may just have to run. So what do you suggest? Should we remove
Okay.
this caps here first before we run power to it? Okay. So so we are going to remove all of this, you say? All of that? Okay. And also, a better, a good isolation is also here, which is, okay, so and if we're to remove this, because if you see this here also, a bunch of caps here. So if you have a short also here, that would also Yeah. So what do you say? We'll remove that also first.
Yeah.
Okay. Just to be sure that the issue is contained only on the line of PP 3.8 volt. Okay. Let's check. It's not a 3.8 volt line, so the issue is this side.
I'm a big player again.
Yeah, so this is a little tricky because we don't want to have a problem with U8100. Uh, yeah, we don't have we don't want to have a problem with U8100. Okay, so we are here at U8100, the region of U8100, and then we are really hoping that we don't want to have a problem with UT100. We don't have a problem replacing it, but we don't want to show want to have a problem with it. Okay, so this is our guy here. It doesn't look to be affected in any way. So our short is either one of the caps here or so. So our short is will probably be in either one of the caps here or the big guy U8100. So what do you reckon we do? So let's see what we can do. It's let's see here. This makes and then that. Okay, so let's remove these two inductors. No, that's a cap. Okay, yeah, it doesn't. It's not really. It's a cap. Let's see what this cap look like. C81DD. Let's see what.
So it's related to big.
Yeah, that's the cap, and it looks good. Yeah, the cap looks good. Okay, so we start from here. Let's start from here. It's not like we have a choice. Okay, so here, wait. Um, mm, 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 mm. Ah, so we start from here. So let's start from these two caps here, and stick these two out first. So we can measure the individual caps. Let's say so if any of it beeps, then we know that's our problem. That's not our problem. Definitely not our problem. Okay, so this two out. Let's come here now. Okay, so this is out, and then that, and then that. Okay, let's do this, and then this. Which is going to be this guy here. And this guy, correct? Good. Okay. What about this guy? Yes, it's also on the line. So this is out, this is out, all of this is out, this is out. So we need to take that out, this, and that, yeah? Okay. So it's that, that. So it's this, and then top, the two at the top. Okay. So apply a bit of soda across. Okay, so what do we do? Measure the caps or measure the line? Okay, measuring the cap just delays. Let's just measure the line. Yeah, let's just measure the line. It's fine. Let's just measure the line. So first, let's just confirm that yeah, we're getting the beep, and then the line. Do we get a beep? No beep. Okay. Bismillah. Haha. Okay, that is beautiful. Our shirt is gone. So, which means one of the caps is the problem. Alhamdulillah, we don't have to go to UT 100. We don't want to come here now. We don't want to come here. Okay, so our problem is definitely one of these caps here. So, what you now just want to do quickly is to now go around the caps and see which one exactly this. That's not our problem. That's not our problem. And then this guy here, okay, that's not out. That's it. That's not our problem. 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 Not our problem. Okay, wait. It's almost like we've gone through all of the caps. And then you? What's happening? Are we happy for nothing? Did we measure a wrong line? Just check again, because if we don't find any of the cap, okay, we still don't have a short. Okay, fine, but okay, so let's just take all the caps out. Like, let's just bring all of the caps out of the board and then check to know, because one of the caps should be, yeah, one of the caps should be, but we don't, for some reason every of the cap it's claiming to be okay when we know that's not the case. Is that all the caps? Looks like it.
Next to the polar.
This one? No, it's not. We didn't take that out. Okay, so now let's see. One, no. Two, no. Wait, no, 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 no. Ah, that's our guy. Our guy was hiding away, so that is our guy. And do you see that it doesn't even look,
David,
yeah, you wouldn't think that's the guy. It looks perfectly fine. It looks perfectly fine. It looks, there is no sign of, okay, that's our guy. We can now put back to rest. You're thinking, oh, what if one more than one failed, yeah?
yeah.
Oftentimes you just get one of it. I'm still gonna flow them in place. First, we wanna assemble them, and then here. But but for record purposes, we did not capture where that cap came from.
Yeah.
I mean, so next time you kind of know, check that guy. But yeah. Did you take anything out? Yeah, we did. Okay. Okay, we need two here. Someone, can we have M1 boards that line? Yes. They go down. Yeah. Let's see. Yeah, this is fine. Okay, now we can float them in place. Seem to be one also here. Here seems to be one there also. Someone take the board. Okay, let's just compare. Let's have another board just to compare what we did to make sure we did not put a cap where there's not supposed to be one. So we know that we're supposed to have that there, that's there, it's three there, and then three straight line, two on top, one, two, three, one here, and then straight line, and then one. We have one here, we have one there, one there. Okay, it's pretty much looks to be okay. So next thing we want to do is see, do we have a short on our PP3V3 with 3V? That's ground. What we can, okay, yeah, we can just check here, and we don't have a short. So the next thing we're going to do is to clean this section of the board, and then test it and see if we have a working board. So can we have a brush? Okay. 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 Let's see what the multimeter says. Okay, so we're expecting to have 12.0 here, which would mean that we have 20 volt on the board on the VPDC line. But if we get 12.27, 28, 30, then it means we're still getting 5 volt on our PPDC line. That's beautiful. That tells us we have a 20 volt on our PPDC line. We can just confirm that. I check in one of our PPDC in fuse, and that's a beautiful 20 volt. And by the way, the reason why that says OL is because we set the voltage to 20 volt, and what we measure it's a voltage higher than 20. So if we put it to 20 200 volt, yeah, we should be able to. So it's because of that that they say. Okay, yeah, that looks good. Let's now see that can we have one, just one? Let's now see that we have a beautiful Apple logo, and that will be it. Well, you don't have any question, yeah? No question. Okay. See that? Looks like that is partially. You see that?
Keyboard needs
Yeah,
more
just a
time.
little bit, because you know that's something. Sometimes afterwards you realize that your battery is not communicating, and then if you ask yourself what's going on. Okay, so we're just gonna have minimal cables to enable us to do the test. Jackpot is connected. And by the way, just so you guys know, the keyboard gets power through the trackpad. So so if I connect the trackpad without me connecting the keyboard, my trackpad will work. But if I connect just the keyboard without connecting the trackpad, the keyboard will not work because the trackpad is not connected.
Okay.
Do you understand?
Yeah.
But if I connect just the trackpad, even
The
though
keyboard.
the keyboard is not physically connected through the trackpad. Do you understand? So you see, this is yeah.
Yeah.
So, but if I don't connect the trackpad because of the circuitry, the design is such that the trackpad, the keyboard is routed through the trackpad. So if you do not connect, in terms of functionality, so if you don't connect the trackpad, the keyboard is not going to function. But I can connect my trackpad without my, so which just means that the keyboard is dependent on the trackpad. So I'm not going to connect that because I don't really need that. But then let's put a fan on. Uh, okay, and then the battery screw.
So on this new designs, if you don't connect the keyboard, does the
Okay.
fan runs crazy? Only if you connect the trackpad.
No, no, no. So there is no sensor on the keyboard. It's on the, so there is that type of sensor that you're referring to is not on the keyboard but on the trackpad.
Oh,
So if you don't connect the trackpad, that's where it's going to run slow, and then the fan,
okay.
yeah, but not the keyboard. Whether the keyboard is connected or not, it's still going to work fine. And also for the newer designs, also if you don't connect the battery, that may also make it boot slow. So it's going to be slow, and even sometimes, like for example, like the MacBook Airs, you may even get the device running, the fan becoming super crazy just because the fan is the battery is not connected. Okay, so just minimum cables, DC jack, screen cable, fan, one speaker at least to enjoy the dong sound, and then trackpad. Okay, so now we can connect power to it. And then that's a beautiful Apple logo. So we don't want this to continue booting. This, as you guys can see, it's a working machine. We are, because we don't want it to put into a client's data screen. So this is now going to be taken over by Peter. Thank you guys. I will see you guys in the next one.